There is a little device, a little USB device called the Wi-Fi. It's a spectrum analyzer. But what's really cool about it is if you look at the two top graphs, you can see all of the traffic that is being generated through all of the wireless frequencies within the 2.4 range. There are 11 channels in the 2.4 range, but there's a huge overlap between them. One overlaps with 2, 3, 4, and 5, 2 overlaps with 1, 3, 5, 6, etc. And when you're trying to explain this to students, you go and you try to draw it on the board, and they all look at you like, okay, go away. It's Starbucks time. But this brings it in really, really, really solidly. If you look at the 3, it looks like basically like the Loch Ness Monster. You can see over here, channel 1, channel 6, and channel 11. And these are the actual ranges of all of the not of all the frequencies, but you can see the overlap that it happens. So if you're trying to broadcast on channel 1, you're right there. If anybody tries to set up an access point on channel 2, what they're going to do is they're going to be smack in the middle of channel 1's frequency range, and so now you have all kinds of havoc.
Because when you transmit on a particular channel, it's this wide. It's this wide, and it's this wide, and it's this wide. So which is why we say when you broadcast, use channel 1, 6, and 11, because if you're using 2, 3, or 4, you're going to be broadcasting in the middle of all this stuff already, and you're just going to get a ton of interference.
Yeah, so that's kind of really brings the point home into a classroom when you're trying to explain to students why you have the gap of the frequency. And you could do it if you bring in 2 access points into your classroom, and assuming your classroom can be fairly wireless, Wi-Fi isolated, set them for like channels 2 and 7 or 3 and 8. And you will see the humps basically adjust over.
Yeah.
So you can see how it works. And the visual really does help the students a lot.
Okay, but what it does, we put them in the labs group, we have them install the software, bring the graph up, then I have them walk around the building looking at all the different wireless signals, and I have them go down to the break area and put their laptop on top of the microwave, start the microwave up, and what do you think happens to this graph? Yeah, it lights up like a Christmas tree. Yeah, so the kids really enjoy that. That's one lab that you can do with these things.
Yeah, so it's real fun. For Wireshark, I don't know if anybody's familiar with it. And what we're going to do is suck some of the packets off the network and judge. Now, the one thing with a standard environment, you can only read the packets that you are transmitting over the wireless. You would have to have a wireless access device that can go into promiscuous mode, so it can then suck off other packets. Anyway, but it's just a little experiment to show how you can actually pull packets off of a wireless network just as easily as you could off of a wired Ethernet network. So you simply connect your wireless AP to the internet. We've done that. We've installed the wireless client on the laptop. Obviously that's working, as well as then connect or associate with it. So if you want to associate, you'll probably see an AP out there by the name of Wi-Fi SEC, Wi-Fi Security, Wi-Fi SEC. The passphrase, it's WPA2, and the passphrase is real complex. Password 1 with a capital P.
80%, right?
Mm-hmm.
Okay.
Yep. I wanted to keep it simple, kind of. Okay, so with Wireshark installed, again, free software. If you haven't used it, it's excellent. There's a great book on Wireshark written by Laura Chappell, and it's available. It's not, I don't know if it's available at Amazon, but it's something, it is? Okay. Okay, so the only things we need to do now is tell Wireshark what interface that we like to use, because Wireshark can, of course, detect anything. Now again, it's local at this point, although you can set it up in promiscuous mode with the right technology. So I'm going to go ahead, click on the capture, and now I'm going to specify what interface I want to capture on. I have the ability to capture, now I have VMware running on this computer, so I could pull down off of one of the VMwares, but I'm going to pull it off the wireless network connection right down here. Okay, so these are the packets. Now, a lot of these are just basically your hello packets, basically ARPs and things like that.
Can you explain a little bit about the Wireshark software, what we're looking at here on the screen, if you
Okay,
would,
what you're
please?
looking at is the top frame basically gives you a very broad overview of what packets are coming in. So you obviously packet numbers, timestamp, source IP address, everything on our little networks, 192.168.1, I said, very common. Destination, where you're going, what protocol, the length of the packet, some information. Now, this is actually the information in a selected packet in, of course, hex, and if it can translate it. Now, what I want to do is in the middle, this actually shows you the entire payload of all of the headers for all of the layers. So you have, obviously, you're going to have an IP layer, a TCP layer, or UDP. You'll also have your frame layer. So your frame layer is what we were talking about as we go through. Now, this is for the particular frame that I have selected up here. If I leave that in place and I open up a web browser, and I come over here to Google, and let's say I go to a website like www.yahoo.com. Yes, she did. Everybody wanted to know that yesterday. That was the most important thing. If you would go down and look into basically the packets coming in, might have pulled in too many. So you could actually see, so we do have
Yeah,
some.
there's Yahoo right there. Yeah, right
Where's
here.
that? Oh, cool.
Okay.
Good, I was closer than I thought. Okay. So you can actually see what the packets are. Now, I'm not going to go into Wireshark much more than this because you could spend a week working with it. But it's a great program. Takes a little bit of time to get used to looking at it and finding things. What's really interesting is if you do this, I guess in Linux, on the wireless, and now you're pulling all the wireless packets that are in the air.
You can do it on the Mac.
And on the Mac? That's kind of scary.
Tell me, if you would, how this, where we got Yahoo up here,
Okay.
relates to Yahoo down here in the bottom pane, please.
Okay. So what you're seeing is the actual packet contents in hex. This is the hex that's coming down the wire. And here, it's, this is the contents of the packets. And obviously we went to news.search.yahoo.com. So there's the website you went for. So if you have people that are searching sites and you're sitting there, you can say, so which one of my employees is searching eBay for, or
Very
monster.com looking for a new job? What really gets to be interesting is when you look at actually what's in the detail of the headers. So this would be the detail for the frame information. If you want to look at the IP information, so obviously we're using version 4. The total length of the packet is 67. Header checksum is the error correction. But what's really cool is you start looking at things like source IP destination. So this is when I can love telling my students, see, your destination is not yahoo.com because it's out on the internet or it's not on your local network. What happened is your packet got sent out to the router because that's your default gateway. That really kind of comes back in great when you get into, you're teaching Cisco and you want to try to explain, well, this is what's happening. This gives you very, very granular data on where it's going. Obviously, we know this is running UDP here because this is the DNS search. We all know DNS runs on port 53 on the destination, but the source port, random number, the random number 50,000 and above. So this is a really nice way of looking into where you're going. So this was the resolution of yahoo.com, or in this case, search.yahoo.com. Dropping back with its return IP address would be the return DNS packet after all the recursion. And then your browser, if we continue down, we could find the actual redirect to the website.
Okay, question. if I logged, let's say you had your Wireshark running in promiscuous mode, and you're capturing all the data in the area, and I logged into my bank account, and you captured that, what would show up down here?
It depends. Don't you love that line? If you are on a secure site running under, let's say, SSL,
Or HTTPS?
then you would not see your bank account information if all of the packets were encrypted.
So what would be here?
Just random.
Would it be encrypted data is my question?
Yes, the data would be encrypted.
Okay.
Now, if you, let's say, put in a username and a password, and that was not being encrypted by whoever you're logging into, which is another reason why you always look for SSL, HTTPS.
Why you don't use Telnet anymore, you use
Right.
Secure Shell.
You will see usernames and passwords going through. So yes, if you're using HTTPS, any of the data here will be. Now, if you obviously use things like man-in-the-middle attacks, then you can sometimes pull that stuff off.
Okay, so if I was transmitting, let's say I had 2 computers in my home, and I'm transmitting data from computer A to computer B through the wireless router. And it was open, it wasn't encrypted, and if you were sitting in the street running this, you could actually capture that data that I'm transmitting between computer A and computer B, is that
Yes, you
correct?
could. Yep.
Okay.
Yep. In fact, what a lot of people don't realize is that, oh, I'm on my home network, that's very secure. Because I'm running, I'm running my own wireless environment. Well, like we've all said, wireless is insecure by definition. Unless you're running a protocol that encrypts any traffic in the air, anybody within range. So if, let's say, I'm just simply copying a file over from one computer to another, and that file just happens to contain all of my bank account information, I keep everything in a
An
Word
Excel
document.
spreadsheet, for example.
Yeah, boom, all of a sudden I can pull it in. In fact, if it's a file, if with some special software, I can even extract it. I don't have to just look at this. I can just suck the file off as it goes over the wire. Yeah, Wireshark can do that. So, yeah,